Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy like the Milky Way. Our knowledge of the universe grows a lot every year as scientists all over the world make amazing discoveries that change what we know. Today, we're going to talk about some of the newest and less well-known discoveries that even the most experienced experts can't figure out. Join us as we explore the depths of space and find secrets that help us get closer to solving some of the most important questions in the universe. We'll look at strange exoplanets that might break the rules of physics and strange cosmic events that no one has been able to explain. Imagine that a planet was found in the outer parts of our solar system that follows its star backward compared to other planets. Not only would such a find be interesting, but it would also call into question current ideas about how planetary systems form. Researchers have recently found some of these strange exoplanets. For example, some orbit their stars in very close orbits, which makes the surface very hot and able to melt metals. Others are rogue planets that wander through the galaxy without a star. This makes people wonder where they came from and how they stay alive in the harsh environment of space. Understanding the complexities of these mysterious heavenly bodies greatly expands the field of science. This has effects on both academic interest and practical issues, such as how we might live on other worlds in the future. Each new finding is a key piece in putting the big puzzle of the universe together. Think about what it would mean to find water vapor on a faraway world, or find a planet with an atmosphere like Earth's. These results could show where conditions are right for life to start, which could help plan future trips to these faraway places. Understanding the unique shapes and behaviors of these planets also helps scientists improve their models of the structure and development of the universe, giving us clues about the past and future of Earth. Imagine that we find an exoplanet whose path isn't smooth, which goes against current theories of gravity and makes us question what we think we know about physics and how things move in space. Not only is this kind of information useful for school, but it will also have long-term effects on technology and space research. The finding of 2007 or 10, the largest world in our solar system that hasn't been named yet, is an interesting case study in how to find and study celestial bodies. This faraway object, which is in the scattered disk region beyond Neptune, gives astronomers both new tasks and chances. Astronomers found 2007 or 10 for the first time while using the Samuel-Oskin telescope at Palomar Observatory for a regular check. It was confirmed to have been found by looking at pre-discovery pictures made by the Spacewatch project. This shows how space science is often collaborative and like a detective story. 2007 or 10 is the third largest known dwarf planet in our solar system. Its diameter is about 1,535 kilometers, which makes it a very big planet. Even though it is very big, it doesn't have a name yet because we don't fully understand its orbit and haven't been able to figure it out enough to meet the International Astronomical Union standards for naming objects. Its surface is mysteriously dark and red, which suggests that it contains complex organic compounds called tholins. These are made when sunlight hits simple organic compounds like methane and ammonia. Did you know that despite its vast size, 2007 or 10 remains unnamed because its orbit has not been determined with enough accuracy to grant it a formal name? Its dark surface and slow rotation make it one of the solar system's most elusive objects. The study of 2007 or 10 includes both direct observations and computer models that try to guess its path and figure out its physical properties. To gather information, astronomers use both telescopes on the ground and platforms in space, such as the Hubble Space Telescope. The light curves from these observations help us figure out its unusually slow rotation period. It takes about 45 hours to finish a rotation, making it one of the Kuiper Belt objects that rotates the slowest. Just when you thought we knew everything there is to know about our solar system, discoveries like 2007 or 10 come along to challenge our perspectives. But hold on, what we discovered next about another distant celestial body might just redefine the impossible. This introduction to 2007 or 10 not only sets the stage for a deeper look into strange celestial bodies, but it also shows how we are still finding new things in the outer solar system. Every piece of information we get helps us learn more about these faraway worlds and the universe as a whole. Ultra-hot Neptunes are a fascinating and rare class of extrasolar planets that defy traditional planetary behaviors. These planets orbit extremely close to their host stars, much closer than Mercury is to the Sun, leading to extraordinary conditions. Surface temperatures on ultra-hot Neptunes can soar above 1,700 degrees Celsius 392 degrees Fahrenheit. Such extreme proximity to their stars creates conditions that challenge our understanding of planetary formation, stability, and atmospheric retention. What makes ultra-hot Neptunes so unique? The intense radiation and stellar winds these planets endure can cause atmospheric blow-off, a phenomenon where the planet's atmosphere is stripped away by the star's energy. This makes their existence even more puzzling, as the harsh environment seems hostile to long-term planetary survival. Take, for example, KLT 9b, an ultra-hot Neptune that experiences such extreme heat that water molecules cannot survive, breaking apart into their atomic components, like hydrogen. Studying planets like KLT 9b helps scientists refine their models of planetary classification and formation. Observing these objects under such extreme conditions also tests our understanding of atmospheric behavior and raises intriguing questions about the diversity and resilience of planetary systems across the universe. Why are ultra-hot Neptunes so rare? The scarcity of ultra-hot Neptunes could be tied to their unique formation process and the specific conditions required for their survival. Their close orbits suggest that they may have migrated inward from more distant regions of their star systems, where they initially formed. During this migration, some planets may lose their atmospheres entirely, leaving behind bare rocky cores, which could explain why we see more hot Jupiters, larger gas giants, and hot super-Earths, smaller rocky planets, in similar orbits. Additionally, the gravitational and radiation effects from their host stars might limit their ability to retain gaseous atmospheres, making their survival a rare event. Understanding why ultra-hot Neptunes exist at all could unlock new insights into the delicate balance of planetary formation and destruction. If ultra-hot Neptunes intrigue you, wait until you learn about other mysterious celestial objects like AYS 134834, a very large star that has revealed surprising clues about the formation of massive planetary and stellar systems. Scientists studying AYS 134834 are uncovering details that could redefine our understanding of how celestial giants come into existence. This shift from ultra-hot Neptunes to other extreme cosmic phenomena highlights how science continuously evolves as we discover more about the universe's most unusual and challenging environments. Each finding builds upon previous research, pushing the boundaries of what we know and encouraging us to question long-held assumptions. The rarity of ultra-hot Neptunes is one of the most intriguing mysteries in planetary science. These fascinating exoplanets, with their scorching surface temperatures and perilous proximity to their host stars, stand out as both an enigma and a valuable piece of the larger cosmic puzzle. Could their scarcity point to fundamental patterns in planetary formation and evolution? Or are they just rare anomalies in the grand design of the universe? Let's explore some possibilities and the questions they raise. A window into planetary formation. One possible reason for the rarity of ultra-hot Neptunes lies in the delicate and tumultuous process of planetary formation. Planets form from the protoplanetary disks of gas and dust that orbit young stars. For a Neptune-sized planet to become ultra-hot, it must migrate extremely close to its host star, likely from a much farther orbit where it originally formed. This migration process is fraught with challenges. A planet venturing too close to its star risks having its atmosphere stripped away entirely, leaving behind a barren rocky core. This might explain why we observe more hot super-Earths, rocky planets with thin or no atmospheres, in similar orbits, but only a few ultra-hot Neptunes, which still retain their gaseous envelopes. The forces required for a Neptune-sized planet to migrate inward and still maintain an atmosphere, despite intense radiation and stellar winds, are likely a rare combination. The role of host stars. Another factor contributing to their rarity could be the type of star they orbit. Stars vary widely in size, temperature, and activity. Larger, hotter stars emit stronger radiation and more intense stellar winds, which can quickly erode a planet's atmosphere. For a Neptune-like planet to remain intact in such an environment, the balance between its gravity, atmospheric composition, and the star's characteristics must be extraordinarily precise. Additionally, the host star's life cycle might play a role. Ultra-hot Neptunes are more likely to be found around younger stars, as older stars would have had more time to strip away their planet's atmospheres completely. This suggests that the ultra-hot Neptunes we do observe may only exist for a brief window of time before transitioning into something else entirely, perhaps a hot super-Earth or a bare rocky core. Are ultra-hot Neptunes clues to cosmic patterns? The scarcity of ultra-hot Neptunes could indeed hint at larger cosmic patterns. Their existence challenges our understanding of planetary classification systems, which traditionally group planets into categories like gas giants, ice giants, and rocky worlds. Ultra-hot Neptunes blur the lines between these groups, suggesting that there may be more fluidity in planetary types than previously thought. Their rarity could also reflect a broader pattern in the universe, where certain types of planets are more likely to form and survive than others. For instance, the high prevalence of hot Jupiters, larger gas giants in similar close orbits, compared to ultra-hot Neptunes may indicate that larger planets are better equipped to withstand the harsh conditions of close stellar orbits. Are they anomalies or part of a greater design? It's tempting to think of ultra-hot Neptunes as mere anomalies, outliers in the statistical distribution of exoplanets. But anomalies often hold the key to deeper truths. By studying these rare worlds, scientists can refine their models of planetary formation, migration, and atmospheric behavior. Each discovery adds a piece to the puzzle, revealing the incredible diversity and resilience of planetary systems throughout the cosmos. Looking ahead, more mysteries await. If ultra-hot Neptunes pique your curiosity, consider the many other celestial wonders waiting to be explored. For example, AYS 13-4834, a massive star surrounded by unexpected features, offers a fresh perspective on the formation of stellar giants and their planetary companions. These extreme objects push the limits of what we think we know about the universe, challenging us to question and expand our understanding of the cosmos. Share your thoughts. What do you think? Are ultra-hot Neptunes a clue to a hidden order in planetary evolution, or are they simply rare occurrences in a universe full of surprises? Let us know your thoughts in the comments below. And don't forget to stay tuned for more deep dives into the universe's most extreme and mysterious phenomena. From blazing hot planets to colossal stars, the cosmos never ceases to amaze.